All right, this is going to be the last new thing that you guys learn for the semester. You're almost there. So, yesterday you learned about the Pythagorean theorem and right triangles, and today we're going to be talking about some similarity that happens in right triangles, okay? So, basically, we have a right triangle here, and we've drawn a line down the middle, okay? So, this is a right angle, even though it doesn't say it. It wants to fill in the missing angles in the triangle below. So number one, if we have a right angle on this side, that means we have to have a right angle on this side because these two angles have to add up to 180. If we want to figure out what this angle is down here, we're going to do 90 minus 53, and that is going to give us 37. And if we want to figure out what this angle is over here, well, we're going to do 90 minus 37. And that is 53. So we kind of have this weird situation going on where, and by the way, 37 plus 53 equals 90, which means that this angle is 90 degrees. But we've got this weird situation going on where we kind of have three triangles. So we have the original triangle, and its angles were 90, 53, and 37. We have this triangle over here, and its angles are also 90, 53, and 37. And then we also have this triangle over here, and his angles are 90, 53, and 37. So all three triangles have the same angles, which means all three triangles are similar to each other, okay? And that's basically what I'm saying right here. They are similar because they have the same angles. Or if we wanted to use our theorems, we could just say because of a similarity, because remember, you only need two angles to know that they're similar, but we know all three. And so this line that we drew here, right, that line, that's called an altitude, okay? So if you think about science class, altitude, you might have heard this word in the context of mountains, right? If you think about this as a mountain, this is the altitude, which is the height of the mountain. So the altitude is just a line drawn from the vertex of a triangle to the base, and it is perpendicular to that base, okay? And you can kind of think of it as the height of the triangle with how the triangle is facing right now, okay? And so when you draw an altitude like this, you create similar triangles, which is what we kind of showed up here. So you can use this to solve problems in some pretty interesting ways. Now, I'm just kind of going to break this down to you in the easiest way possible, all right? You want to set up a proportion, just like we kind of practiced in the last unit, okay? And you want to set up a proportion from basically your right triangle, which is this purple triangle, and let's make the other color green, this green triangle, okay? Now, when you do this, okay, what you're going to do is you are going to, so let's look at the purple triangle, all right? It doesn't really matter how you set this up as long as you do the same thing both times. So I think the easiest way is to do 16. So 16 and put that on top. Okay, so you're going to, put that on top. So we're going to put 16 over here, and then we're going to put x on the bottom. Okay? So we've got 16 over x. Now, what side does x match up to, right? So if I take this purple triangle, There's no way I'm going to be able to get this purple line without the green line, is there? Yes. Okay, so it's coming down and it's being rotated, right? So if you look at where this x side is, this x side is going down and it's becoming the 84. And then the 16 side is rotating up and it's becoming the x, right? So if we look at the green triangle, the x becomes 84. So we want to have the 84 down here. The 16 is becoming the x. So we want to have the x up here. Now, here is the easiest way to know how to do this, okay? The x's, so basically the middle part, the altitude, right? It is always going to be up on one side, down on the other side. It doesn't matter if it's flip-flopped. It could be 84 over x and x over 16. But regardless, they should be across from each other like this, okay? You should not have the x's on the same level. Similarly, or not necessarily the x, but whatever is on the altitude, right? So this is how you know that you've set it up correctly, is if whatever the altitude part is, if that part is up on one side, down on the other side, and now you are just going to solve this. Okay, so we're gonna cross multiply 84 times 16. I need a calculator, I don't know what that is. Wow, 1,344. And then we have x times x, and that's x squared. And now we can take the square root of both sides. So let's see, what is the square root of 1,344? It is 36.7. So our answer is 36.7. Okay, and that's how you solve that. Now, that was kind of me explaining more than you necessarily need. We're going to look at another one. So let's look at our first triangle on the left. So let's do x over 12. That means in the second side, since 12, which 12 is the altitude, right? So since 12 was on the bottom on the left side, we're going to put it on top on the right side, and it's going to be over 16. So this is how easily you can set this up. Like, really, once you do like a few of them, you should start being able to set it up like in like 2 seconds. So let's go ahead and multiply. So we got 12 times 12 is 144. And then you got 16 times x is 16x. So here we don't have a squared. That's because the x is down here. So the 12 is the altitude. The 12 is what is appearing twice. And we just want to divide by 16. And so we get x equals 9. And that is how you do these problems, okay? So you guys have 10 problems that I want you to try. You're basically just doing the same thing as what we did up here, okay? If you have more questions or if you're still confused, I'll try and find another video up there. Maybe they'll explain it better. But other than that, good luck studying for your test. Good luck studying for your midterm, and I will see you guys later.